Okay, so we know the three main subatomic particles that atoms are made out of. We know how they're organized. Now, the next thing we're going to go through is we're going to identify, well, each atom of an element, right? So let's say each element, this is better, each element has atoms that have different numbers and arrangements of these subatomic particles. And so the number of protons will tell you something unique about that particular atom. The number of neutrons, again, will tell you something different about that atom. And the electrons, yet again, will tell you something else about that atom. So we have to identify what kinds of characteristics or properties do these subatomic particles confer to an atom of an element. So along with this, we're going to talk a little bit about nomenclature and some of these new, perhaps, vocabulary words like atomic number, and atomic mass. So first of all, an element's atomic number is going to be the number of protons in its nucleus. Okay, let me pause here just for a second, and let's draw this out. So we're going to use carbon as our example. So every element has a symbol. All right, so carbon, and we'll take a look at the periodic table of elements in a little bit, but there's carbon. Carbon uses the letter C as its element symbol. Sometimes a symbol is a single letter, but there are multiple elements that start with the same first letter, and so sometimes it might be a two-letter element symbol. In this case, it's carbon. Now, imagine we've got a box drawn around this letter C, and we've got points, right, or corners to this box. If we put a number at each one of those corners, it's going to mean something else. So the atomic number for carbon, or the number of protons it has in an atom of carbon, the atomic number always goes in the lower right-hand corner. And so the atomic number for carbon is 6. That means that carbon has 6 protons in every atom of carbon in the nucleus. Okay, so that's your atomic number. Next thing is the element's mass number. Mass number is going to be the sum of protons plus neutrons in the nucleus. Okay, so let's go back. So this guy right here was the atomic number. The mass number is going to be written up here. So the mass number of this atom we're looking at, I'm going to say is 12. So this is the mass number. Remember, the mass number is equal to the number of protons plus the number of neutrons in the atomic nucleus of this atom. So that means if we have the atomic number, we have the mass number, we know the number of protons, we can figure out the number of neutrons this particular atom has, right? So the mass number was 12, and we know that it has 6 protons because that's the atomic number. What's the number of neutrons? Hopefully you said 6, right? So this particular atom has 6 protons and 6 neutrons. Okay, and then lastly, an element is matter, right? It takes up space and it has mass. Each atom of an element has mass, and we call this mass the atomic mass. Makes a lot of sense. It's the mass of the atom. You can calculate the atom's total mass simply by adding up all of the masses of the individual subatomic particles. So yeah, even though these subatomic particles are really, really small, they still have mass. So let's go back here and let's introduce the actual masses of the different subatomic particles. So let's start with protons. So a proton has a mass of 1 Dalton. So 1 Dalton. If you have ever heard of AMUs or atomic mass units, a Dalton is the same thing as an atomic mass unit. So no difference there. A neutron also has a mass of 1 Dalton. So far, so good. Pretty easy. Leads us to electrons. Electrons are the smallest out of these 3 subatomic particles. And it is so small that it really has a mass about 1/2000th of a Dalton. It is tiny. And so there are no elements that I know of that have 2,000 electrons to make up 1 Dalton even. So really, we can kind of just say, meh, you know what, an electron, its mass is essentially insignificant. So we're just going to ignore the electrons, even though it's 2,000th of the mass of a proton or neutron. Okay, so with this information now, let's see if we can calculate the mass of this atom of carbon-12. So simply what we're going to do is we're going to add up the masses of all the protons, add up all the masses of the neutrons, and we're ignoring the electrons. So protons, remind me, how many protons does this carbon atom have? Remember, the atomic number will tell you. So it's got 6 protons, and each proton has a mass of 1 Dalton. So we're going to multiply 6 times 1 Dalton. And then we're going to add the masses of all the neutrons. Recall that we can calculate how many neutrons this particular atom has if we have the mass number and if we have the atomic number. So in this case, we've got 6 neutrons, and again, each one has a mass of 1 Dalton. So we'll multiply that by 1. Electrons we're ignoring. Do the math. 6 times 1 is 6, plus 6 times 1 is 6. That would be 12 Daltons. And what you may have noticed is this number right here, our approximation of the mass of the atom, because we're ignoring the electrons and some other good stuff in there too. This number 12 is the same as the mass number. And so if we go back to our slides now, the atomic mass, yes, it's the atom's total mass, but it can be approximated by simply looking at the mass number. This is probably a good time to stop and take a look at the periodic table of elements. So I have a picture here of the full periodic table. And periodic table of elements, depending on which one you're looking at, might give you slightly different information. And we'll look at a different version later on in the slides. But this one is pretty standard. So you'll notice there are a lot of boxes, and each box is going to hold 1 element in that box, right? That's its space. And so this particular periodic table of elements, if we take a look here in the middle, you're going to see in that gray box kind of a key, right? So you have your symbol in the middle, that's going to be the letter. Way at the bottom, that number is going to be the atomic mass, and in the upper left-hand corner you have the atomic number. So if we go back to carbon for a minute, carbon, you can see it on the right-hand side here of the periodic table. And carbon, if you look at the atomic mass, it has an atomic mass of 12.011 Daltons. That's really close to the approximation that we calculated simply using the masses of protons and neutrons and the number of each in that atom. All right, so now one new thing that we have to introduce to the periodic table of elements is kind of how to read it. And you read it like a textbook or any book. You're going to read it from the top of the page to the bottom, each line one at a time going left to right. So our very first element is hydrogen in the upper left-hand corner. You'll notice there's a little 1 in the upper left-hand corner of hydrogen's box. That number 1 doesn't just indicate that it's the first element, but remember, if we look back at the key for this periodic table of elements, that's also the atomic number. So that means that hydrogen, being the first element, has 1 proton in its atomic nucleus. Okay, moving all the way to the other end of that row, we've got helium on the far right side. It is the second element in the periodic table of elements. Number 2 means that it has an atomic number of 2. Helium has 2 protons in its atomic nucleus. That first row is done. We move on to the second row. First element in the second row is lithium. Third element, 3 protons. Beryllium, fourth element, 4 protons. Next, we have, jumping the gap there, boron, fifth element, 5 protons. And then we reach carbon, 6th element, 6 protons. So hopefully you're picking up the pattern. Every single element is going to have a unique number of protons in its atomic nucleus. There are no two elements that have the same atomic number or that have the same number of protons in that nucleus. So we have come now to the conclusion. Remember, we've got three kinds of subatomic particles that we're discussing: protons, neutrons, and electrons. I said that the number and organization of each is going to tell you something unique about that particular atom. So if I were to throw an atom at you, something you've never seen before, and you're able to count the protons, you would know what the atomic number is. You could also tell me which element you have, what element that atom is of.